Okay, again, you got a test tomorrow over this. The other sheet can be put to the side. There's another video with it. It's really easy. Here's what your test is over tomorrow. It's polynomial expressions. All this stuff here are called polynomials. So I've got 4m to the second minus m plus 2, and then the operations plus, which means I don't have to do anything over here. And then negative 3m to the second plus 10m plus 7. So if it's plus or minus operation, we spot our variable and then to the highest exponent. So we got a second power, nothing, and then a second power, m, and nothing. Okay, so the second power is the highest, and after this m to the second comes just m, and then my constant. So m to the second, so I need to go find those. So I have 4m to the second and negative 3m to the second. So that means I need to add 4 plus negative 3. It's a plus. 4 plus negative 3 is 1. Okay, so we have 1m to the second. And we can cross those out. Okay, now for m, well, I have one right here. That would be a negative 1m. And then here I would have a positive 10m. So it's negative 1 plus positive 10. Negative 1 plus 10 is 9. Okay, now I have my constants. My constants are positive 2 and positive 7. So positive 2 plus positive 7 is 9, and then that's the answer. 1m to the second plus 9m plus 9. Okay, my next example, I have 9x to the third minus 13x to the second plus x. That'd be a 1x. And then the operation's minus, so since it's not multiplication, I don't need to do anything here. Okay. Negative 13x to the second minus 5x plus 14. So I have x to the third, x to the second, x, and then x to the second, x, and nothing. So x to the third is my highest power, and that would be followed by blank x to the second plus blank x plus blank. Okay, so for x to the third, I just have 9 here, and then I don't really have any x to the thirds inside of there, so it would just be like having 9 minus 0, which would be 9. Okay, now for x to the second, I have negative 13 and then negative 13. So I have negative 13 and then a subtraction sign and then negative 13. Okay, that gave me 0. So since that is 0, then this x to the second power can be just gotten rid of. Okay, because we don't have any of them when we have 0. Now for regular x, I have positive 1x and negative 5x. So I'm going to take 1 and subtract negative 5. So I'm subtracting a negative, which means it goes up to 6. Okay, and then for constants, I don't have anything here, so that makes 0, and then minus positive 14. So again, that goes in as 0 minus 14, and that's negative 14. Okay, so that's my final answer, 9x to the third power plus 6x plus negative 14. Okay, now my next one, I have 3x to the third. Now the operation then is times, okay, and then I have 8x to the fourth minus 1x to the second minus 3x plus 5. So I have to distribute that 3x to the third to all of these things in here. So to 8, to negative 1, to negative 3, to positive 5. So I just drew 4 rainbows, okay? So I got 3x to the third, 3x to the third, 3x to the third, 3x to the third. And I'm going to be multiplying that then by the 4 different things. So 8x to the fourth, negative 1x to the second, negative 3x, and positive 5. Okay, so now let's make sure all my x's actually have powers. So that's a 3 and a 4, a 3 and a 2, a 3, and this x would be a 1, a 3, and nothing because I don't have x there. So I take 3 multiplied by 8, that'd be 27, or 24, 24, 24, it's 24. Then on x, you have 3 plus 4. Remember, you got to add the exponents. 3 plus 4 is 7, so x to the 7th. Okay, 3 times negative 1 is negative 3. Then on x, we have 3 plus 2, which is 5, so negative 3x to the 5th power. Okay, 3 times negative 3 is negative 9. Then on x, we have 3 plus 1, and that's 4. Okay, 3 times 5 is 15. Then on x is just to the 3rd power. Okay, so since all of these powers are different, I have a 7, a 5, a 4, a 3. They're all different, so I don't need to write the blank spaces out. I just write 24x to the 7th power plus negative 3x to the 5th power plus negative 9x to the 4th power plus 15x to the 3rd power. Okay, and that's my answer. Okay, number 4, I got 3x minus 1, and then that would be a times, so we are going to use this space over here, times 4x plus 9. So first off, let's just focus on the 3x and distribute that to everything in the other parentheses. So I'd have 3x times 4, 3x times 9. Okay, so 3x, 3x, and I'm going to multiply it by 4x and positive 9. And then I'm done with the 3x. Now I do the same thing and distribute the negative 1 to each of these. So negative 1, negative 1, then 4x and 9. Okay, so look at your x's. And that would be a 1 and a 1. This would be a 1 and nothing, a nothing and a 1, and then nothing at all. So 3 times 4 is 12. Then on x, I would have 1 plus 1. 1 plus 1 is 2. So 12x to the 2nd power. 3 times 9 is 27. Then on x, it'd just be the 1. Negative 1 times 4 is negative 4. Then on x, it would just be the 1. Then negative 1 times 9 is negative 9. So I have x to the 2nd, x to the 1, x to the 1, and nothing, okay? So I have 2 of these that are identical powers, so those are like terms that need to be added. So I need to draw my spaces out. So I got blank x to the 2nd plus blank x plus blank. So for x to the 2nd, I have 12. For x, I would add 24 plus 27 plus negative 4. Okay, and that is 23. And then for my constant, I just have the negative 9. That's my answer, 12x to the 2nd plus 23x plus negative 9. Okay, number 5, x plus 4 times 1, it'd be 1x plus 4 times 1x to the 2nd plus 6x minus 5. Okay, so again, it's multiplication, so we're going to need to draw our rainbows. So I go 1x to 1, 1x to 6, 1x to negative 5. So I just drew 3 rainbows now. So I write 1x down 3 times. And then as far as what I'm timesing by, it's just what I drew it to. 1x to the 2nd, 6x, and negative 5. And that takes care of the 1x. Now we'd repeat the process with the positive 4. So positive 4 to 1 to 6 to negative 5. So my factors are 4, 4, and 4. So I'll be multiplying 4 by the same 3 things. 1x to the 2nd, positive 6x, and negative 5. Now we have 6 products we have to find here. Okay, so that would be a 1, and that has a 2. That'd be a 1 and a 1. That'd be a 1, and negative 5 is nothing. Be nothing, 4 is, and then a 2. 4, and then a nothing and a 1, and then nothing at all. Okay, so 1 times 1 is 1. Then on x, we take 1 plus 2, and that's actually 3. So 1x to the third. 1 times 6 is 6, and on x, we take 1 plus 1, and that's to the second. Okay, 1 times negative 5 is negative 5. Then on x, it would just be to the 1. 4 times 1 is 4. Then on x, it would just be to the 2. 4 times 6 is 24. Then on x, it would just be to the 1. Then 4 times negative 5 is negative 20. Okay, so I have x to the third, x to the second, x to the first, and then x to the second, x to the first. So I have some of these that are the same. So I got 6x to the second and 4x to the second. Then for x to the first, I have negative 5x to the first and 24x to the first. So these two are like terms, and so are these two. So I want to draw out my blanks. So it'd be blank x to the third plus blank x to the second plus blank x plus blank. So for x to the third, I have 1, so it'd be 1x to the third. For x to the second, I have 6 and 4. Well, 6 plus 4 is 10, so it'd be 10x to the second. Cross those off. And then for the x, remember, x means x to the first, so negative 5 plus 24, and that's 19. And then we have negative 20 as our constant. Okay, number 6, 3x plus 5 to the second power. Now, whenever I have a power with a plus or a minus, we need to get rid of the power and then just duplicate another parentheses with the same addition expression. So 3x plus 5. So it's a multiplication problem, so I want to circle my first term, and then I distribute the 3 to the 3 and the 3 to the 5. So I had 3x times 3x and 3x, and I'll times that by 3x, and I'll times it by positive 5. And then the 3x here is done. Now I have positive 5. I distribute that to each one of these. So 5, 5, and then I multiply it by the same two things, 3x and 5. So 1, 1, 1, nothing, nothing, 1, and then nothing. Okay, so my product, 3 times 3 is 9. Then on x, it would be 1 plus 1, which is 2, 9x to the second. 3 times 5 is 15, and we would just have an x to the first, because it's just that one. 5 times 3 is 15, same thing, and we again just have x to the first. And 5 times 5 is 25. Now, these two are identical. Those powers are, so we need to draw out the spaces. The highest power I got in a product is x to the second. So blank x to the second plus blank x plus blank. So for x to the second, I got 9. For x, looking at these, 15 plus 15 is 30. And then my last term 25. Okay, now for the word problem, number 7. Picture has a length of 20 inches and a width of 25 inches. You're going to build a rectangular border around the picture. So first off, you got 20 and 25. Now we want to measure the dimensions. So the length gets measured from start to finish, and then we mark where the centerpiece starts and finishes. And we know the outer parts are x because we don't know how wide those are, but I know here if I look straight up, that's 20 units long. Okay, then the width, same idea, start to finish, mark where the center stops and finishes. So we got 25 and then x and x. Okay, so part A, write a polynomial expression that represents the total area of the picture and the border. Okay, so we're going to make two parentheses, one for the length, one for the width. So my length, I have two x's on the outside and then a 20, so we need to write 2x plus 20. And then for the width, we have two x's on the outside, then a 25. So for the width, that's 2x plus 25. If you don't see how I'm getting 2x, it's because I have an x, so that's 2 of them. You have 2. So to find the product, we're going to make our rainbows. First is the 2x. 2x to 2x, 2x to 25. So I put 2x, 2x, and then we're going to multiply it by 2x and by positive 25. Then that takes care of the first 2x. Then the 20 has to be distributed to 2x and 25. So I got 20, 20, and then 2x and 25. Okay, now the products we have. The x's need powers, so 1, 1, 1 and nothing, nothing and 1, and then nothing. So 2 times 2 is 4. Then on x we have 1 plus 1, and that's 2, 4x to the second power. 2 times 25 is 50, and then on x you just have the first power. Then 20 times 2 is 40, and then on x you just have the first power. And then 20 times 25 is 500. Okay? And you don't have any x's to worry about there. 500 is just a constant. Okay, now I have 2 identical powers here with these x to the first, but the second is the highest. So blank x to the second plus blank x plus blank. So for x to the second I have my 4. Then for x I have 50 plus 40, and that's 90. And then I have 500. Okay, and that's all I do for part A. Now part B, use your expression to calculate the width of a frame that is 4 inches. So it's 4 inches. So what that's telling me is that this frame, the frame's the outside part, is 44 inches long. So 4 is going in place of the x, both of them. So I parenthesize these x's, both of them. And now I'm going to empty the parentheses. So I have a 4, and then a parentheses, and in that parentheses we'll be putting 4 to the second power plus 90, and then in that parentheses I put 4, but there won't be a second power on that, and then after that I have to add the 500. Okay, now my calculator can take over from there. I have a 4, and then the parentheses keys here, and then we're going to be putting 4 in, close it. Your second power key is the x to the second button, okay? And then plus 90, parentheses 4, plus 500, and that gives me 924. Okay, so that's the correct answer. 924 square inches is how areas labeled. Okay, that's all I have to say. Hope it was informative.